Hey, so we're going to continue on functions. And we're going to just start with determining if something is a function or if something is not a function. I'm probably going to give a poor explanation for why something is a function. It's a little hard to see why something is necessarily a function when it's given in really simple terms. But the idea is something is a function if it has a unique output for every input. Meaning that if we put something into the function, we don't get more than one thing out of it. Well, we want to determine if the line y equals 2x plus 5 is a function of x. Meaning for every x, do we get a unique y out of it? And yes, because we plug in 1x, multiply by 2, that doesn't change the number of solutions we can have, or add, and then add 5. And that doesn't change anything either. So therefore, it's a function. It's a little bit easier to see why this matters in a case where it breaks down. And so that will be more obvious in this next example, where we want to determine if x squared plus y squared equals 16 is a function of x. Now, let's also think about what this is a graph of. We just covered it a couple videos ago, so stop and think about what this is. All right, hopefully you concluded that it is a circle, and it is a circle. It's centered at 0, 0 with radius 4. And so we can even draw a picture of it. We have 4. We center at 0, 0. We get that the radius is 4 because 4 equals the square root of 16. And remember, 16 was our radius squared. So this is what it looks like. And then we know that if xy is on the circle, then x squared plus y squared equals 16, which is going to tell us that x equals, wow, I didn't write 16, I wrote 0. My apologies. X squared equals 16 minus y squared, or that x equals plus or minus the square root of 16 minus y squared. So what happened is we plugged in, for every value of x we plug in, we actually get 2 values for our y coordinate that are going to work. Or I guess for every y we plug in, we get 2 values for our x coordinate that will work. That's kind of the issue, where if we choose x equals, let's say 3, then our y could be this value or this value. So it's not unique. And therefore, not a function. Because we don't know how to choose which value we want right away. Now there actually is something we can do. We can take this a step further in defining it and just say that we're going to pick the upper half. That's actually how we define the square root as a function by just saying when it's a function, we're just going to take the positive square root. And I guess we already did this above, but for 2x plus 5, before we left it as y equals 2x plus 5, that was because we didn't know it was a function yet. But once we do know it's a function, we often replace it with f of x equals 2x plus 5. So once we have it's a function, we like to introduce the f of x notation. And we're going to pick up with evaluating functions. So we already did a little bit of this, but now we can talk about some function operations. So we have f of x equals 3x plus 5, and g of x equals age. Then we can look for the following: f of 2, f of 4, g of Weston, which hopefully you remember from the previous video. Weston's sister, g of Kanye. And then f of 6 plus g of Matt Damon. All right, so all of these you should be able to answer on your own. So I would give that a shot first. So just pause the video and try and do that. But okay, so hopefully you pause the video and tried it. I'm going to give the answers now. F of 2, where we'll plug in, get 3 of 2 plus 5. That outputs 11. F of 4, same idea. 3 of 4 plus 5, we get 17. G of Weston, 23. G of my sister, 26. G of Kanye, I'm going to look that one up really quick. 43. It's getting up there. And so is Matt Damon, where we have f of 6, which is 3 of 6 plus 5 plus g of Matt Damon. Now, this seems weird to be adding together two functions that are seemingly unrelated, but it works out because they have numbers that are compatible, because g of Matt Damon outputs a number, f of 6 outputs a number, and we can add two numbers together. So whatever this means, our output is 18 plus 5 plus 49, 23 plus 49, and that's 72. So pretty quick, pretty straightforward. We can also multiply, add, divide, subtract functions, provided they have the same range. And it should make sense that they need to have the same range. It'd be weird if you had a function that output values in humans. So maybe you had a function that took in social security numbers and output people associated with them. And you had another function that was just like f of x equals 2x plus 5. So then that SSN function for social security number, SSN of whatever my social security number is, plus G of 5 really wouldn't make any sense at all. So they need to have the same range. All right, and we can also work on finding domain. For domain, we usually make our domain to be as large as possible. So just all values that make sense. We have f of x equals x over x squared minus 1. We can actually factor the bottom. And then notice that our function is defined almost everywhere, except for x equals plus or minus 1. Now, pause the video and think about why x equals plus or minus 1 doesn't work. All right, so we'll see if we plug in x over 1 squared minus 1, we get, I guess that should be 1 up there as well. We're going to get 1 over 0. Alarms should be going off in your head. We can't have this. We can't divide by 0. We don't know how to do it. Can't be done. Doesn't make sense. There's some branches of math that have tried to make it make sense. They're useless. There's something called a wheel. Yeah, it really doesn't work. So we can't divide by 0, and we're happy with that. We didn't want to divide by 0. All right, so then our answer is that our domain, and we can write it in 2 ways. First is interval notation. So this is a way of saying all numbers from the left end of the number line, negative infinity to negative 1, not including negative 1. So when we have a circular bracket or a round bracket, that means we don't include the endpoint. Or x doesn't equal plus or minus 1, or we could have all the real numbers minus plus or minus 1. Lots of different ways to do it. The fact of the matter is you just want to get the point across that plus or minus 1 is not in your domain. Domain of f of x equals x squared. That should be easy. We just write it as r for all real numbers. This kind of script is known as blackboard bold, where you just do the R with the little line through it, presumably because when you're writing on a chalkboard, it's hard to write in bold. And that just means all real numbers. We plug in a real number, we can swear it. We're fine. We're happy with it. Nothing more complicated than that. All right, so that's it for this part of functions.